Okay, probably I am live and I do have some goals for today. So it's basically linear algebra. So let's head on to this. So I'm already learning vector determinants. So there are only two things left in linear algebra, which are matrices and system equations. So first we will start with matrices. Then yeah, matrices are I mean important. So we will read this in depth today. After that we can jump to determinants, which are fairly easy. Okay, so this will be the lecture that I will follow. This one, this is from a course that I bought a long time ago, I believe. So yeah, let's go. Okay, I just got distracted for a minute, but yeah, we can start.
Will be a second row.
So he's basically uh, he's basically giving an example of movie theater where we have rows and columns. Like for rows, we have in the movie theater we have rows like A1, A2, A3, and so on. And and um, for this, it is actually the same. Um, yeah, I can just play the video.
Right.
Should we watch it uh, at a quicker pace? I think so because yeah.
And so on. Right. So this arrangement is nothing but what we call matrices in mathematics, right? And this is what we'll be dealing with.
Okay, it's little too fast. I will just slow it down to 1.5. Oh, okay, we can
This sort
just
of arrangement,
go.
right, is called matrices. All these are rows, right? Row one.
Wait a minute, I have a HFT lab work. Let me just quickly write a message to it, and then I can just do the thing. All right, I believe we can continue. So here we go.
row 2, and so on. This is, for example, row something, right? And all these are columns basically. So this one, if you see, this is column 1, column 2, column 3, column 4, column 5, 6, right? So this arrangement, this arrangement is called matrices, right? So if you're not from a mathematics background, then I think this is the simplest example of matrices, right? Now when we represent it in terms of numerics, right, we can write something like 0.3, 0.5, 8, 9, 1, minus 0.7, right? So this is also a matrix. For example, let us say the name of this matrix is be A, okay? So you see that we have around, not around, we have two rows, row 1 and row 2, and we have three columns. This one is column 1, right? This one is column 2, and this one is column 3, right? So we have matrix A having two rows and three columns. That's why we call order of this matrix as 2 into 3, okay? And so basically this is row, the number of rows, and these are the number of columns, right? One important thing to note down is that we have around 6 elements, right? So this is 2 into 3, 6 elements in the matrix A, okay? All these particular entries are called elements, right? Or sometimes popularly called entries, right? And if
I believe I should just get my lecture note over here so I can see the lecture note in parallel and grasp the topic in a better way. Yep. Okay, so here's one important thing that we have to, like, how we can find the order of the matrix. Then we can find order through this, like this is rows and this is columns. Okay, great.
you want to denote a particular element, so for example, you are sitting in a movie theater and now someone uh, asks you where exactly are you sitting, maybe you can tell J4, right? J5. So in terms of matrix, to denote a particular element, you start with, so for example, first of all, you will be writing the name of that particular matrix, which is A. And now to denote a particular, so you will be denoting the particular row first. So the row that you are in, for example, you are in second row, and the column that you are in, let's say you are in third column, right? So A23, which is basically minus 0.7. So this is how we denote the elements of a matrix, right? Any doubt so far? So if I ask you, what is A12? What will be the value of A12?
This is
0.5.
this is A12.
0.5. So this
Yeah.
is basically, you have to go to the first row and then the second column, right? So this is basically this one, first row and second column. Now let us see some more examples of matrices, right? So maybe this one, A11, A12, A13, A2, A22, A23. So this is also a matrix, right? Now if you see over here, the number of rows are 3 and the number of columns are also 3, right? So the number of rows and number of columns are equal, right? Such matrices are called square matrix, right? So basically, number of rows equal to number of columns, right? So these matrices are called square matrix. Okay. Now there is one another kind of. So this is I think we have defined matrices. Now let us define vector.
So basically, the thing with matrices is, um, like, this is very basic, of course, but what we learned so far, we learned um, how to find the order of matrices. So this is a column, this is a row, and how do we find the order? So if I really want to find where the particular uh, so what's the particular order of any any vector of any unit of a matrix. Let's say this one. So this is in column 1, so 1 cross 3. So yeah, 1 cross 3 will be its value. Okay, we can move ahead. And also we just learned what are square matrices. So any matrices which have same amount of columns and rows, those are square matrices. Let's move on.
Right. So first of all, let us define row vector. So row vectors are nothing but they.
So row vector must be like here, like 1 comma 2, yeah, anything, any number in a row, like in this way. And column vector will be in this way, from up to down. Yeah, row vector will be from left to right, and column vector would be from up to down. That must be the difference.
Will have only, so matrices having only one row. Okay, so for example 3 1 2. Okay, so this particular matrix is having only one row, so that's why we call it a row vector. So this is also a vector, or sometimes we also call it a row matrix. Okay, so but here we will be defining it as a vector. So basically this particular matrix is a row vector. Similarly, we will have a column vector. What will this denote? A matrix having only one column, right? So 1 2. So this is a column vector. Okay, now why do we call it a vector? Okay, so I think you will have a fair understanding of the coordinate system, right? So in your class 9 10, you might have gone through x and y, which is x is abscissa and y is ordinate, right? Have you ever gone through this thing? I think everyone might have, right? The coordinate system. So
Okay.
this is something
Yeah.
called x coordinate. This is y coordinate, right? This one is origin, and you will have 1 2. So this might be 1. This might be 1. So you'll have 1 2 around here, right? So x is 1, y is 2. So now this particular vector is denoted by this one, right? So this is a vector. So the line joining the point, 1 2 and the origin is called this vector, particular vector, and we denote it by this particular column vector, right? That's why we call it a column vector. Otherwise, you can call it a column matrix as well. That's not an issue. Any doubt so far?
Wait, I have
A
to.
column matrix as well. We denote it by joining the particular vector is denoted by this one, right? So this is a vector. So the line joining the point, 1 2 and the origin is called this vector, particular vector, and we denote it by this particular column vector, right? That's why we call it a column vector. Otherwise, you can call it a column matrix as well. That's not an issue. Any doubt so far? Any doubt?
Okay, so what I think, why we should call it a column vector? Why can't we call it a row vector? Like suppose if it's 1 comma 2 from left to right, so at that time we should call it a row vector, right? But so what's the actual difference uh, between referring row vector or column vector? I have to see that. Okay, never mind. I will just go through this. um, okay, probably we will know a bit more about this thing in next few minutes. If not, then I will just AI search it. Okay.
Kshitiz, why
Yeah.
that I think a column vector includes only the coordinates of column, and x and y axis denotes both column and rows. So why is it similar?
I could you please repeat again?
So basically, x and y axis both denotes rows and columns, right?
X and Y axis both denotes rows and
Like
columns.
for example,
Yeah, please feel free to ask. I will be.
x denotes rows and y denotes columns. So why do we have column vector plotted there?
Okay,
Like
so what
that
I
should
mean,
be
if you're asking this particular question, this can also be denoted using 1 and 2. Okay, so this is like either you write it at x, y, z. Basically, if you have three axis system, or you can write it x, y, z as well. So it depends on particular convention that you are using. So you can either write x, y, z, or basically as a row vector, or you can write this particular vector as a column vector as well.
okay.
Got it?
Yeah.
Yeah, so there's no such difference like that. We can just refer to it uh, as we like. All right, let's move ahead, I guess. Probably next is, okay, let's see what's
Okay,
next.
so in case you are still not convinced, please feel free to ask.
No, go ahead.
Okay, sure. So basically, what I try to convey is, for example, let us say again, let us again take a point on the xy coordinate, right? So maybe this point 3 and 2, right? So this is point 3 and 2. This is the point 0. This will be a vector, right? Which will be connecting the point 3 and 2. This one is x coordinate. This one is y coordinate of the point, right? And this one is a vector connecting that particular point to the origin, right? And that's why we will be denoting this one as either 3 or 2, or 3 and 2. So depends on what convention are we using, right? So if we are denoting using this one, this will be a kind of a row vector. If we are denoting like this, it is kind of column vector, right? Okay. So now if I again define the matrix. So matrix is nothing but a rectangular array of numbers, right? Uh, and we have taken a few examples of matrices. So now let us see some operations on matrices, right? So if we take one more example of matrix, let us say this is one matrix, right? Maybe minus 2, 6, 0, 7, 9. So this is one matrix, and this one is another, which we will be calling matrix B. Okay. So 3, 4, 2, 9, 1, 8. Okay. Let us write 4 like this, otherwise it tends to.
I believe this is kind of slow, so I will just run it fast again. I believe I can understand his wordings, but yeah, because I know these things, so I can just skim through this. Okay, I will just see what he's teaching next. Like, I can't even
Okay. Yeah.
like move ahead. Okay, I can move ahead. It's addition. So if we add, so let's add the matrices. So if we add this, then it would be -1. No, it would be 1 and 1 10 2, 1 10 2, and then 16 10 11, 1 10 2 16 10 11. Yeah, that would be it. Let's see if we are correct. 1 10 2 16 10 11. So yeah, we are right. So I believe we can move ahead with this. Subtraction, it's simple subtraction too. So -2 minus 3, yeah, -5 that side. Okay, that's the most complicated term it got written. So then 2, and then -2, and then -2 again, 8, and -5. Okay, let's see. It's same as I said. Let's go to multiplication. Okay, it's scalar multiplication, so um that would be fine. And if there is term like k, then we have to multiply this this thing, this number, with all the terms here. So with all them in our original matrix. So we can just multiply 5 with the original matrix. Original matrix was -2 6 0 7 9 3. Okay, so we can just multiply it. So -10, 30, 0, 35, 35, 45, 15. That should be the answer here. Yeah, yeah. So we will just look on to the properties. mm, yeah, we can just do it in any way. Normal algebraic properties, it's nothing much. Wait, I have to understand this property. So basically, I got into one HFT lab. So they are uh, just I can show because it's on my other device. So they are just trying to recreate three papers of market making. Okay, I guess we have to read things a little too quick because we will be working on recreating a market making paper. So yeah. Okay, so I do have to finish the mathematical approach as quickly as possible because I do have to implement the CG model of with the mean reversion of one of the paper. So yeah, that would be fun. So basically, I do have to have the mathematical, I mean mathematical approach of this paper, like understanding the paper. Okay, I'm taking a good amount of pause here, but it's important. Okay, let me just okay, we can do this basic, it is important of course, but let me just see the paper that I want to recreate. So I have to recreate CJ model paper. So CJ model, CJ model with mean reversion, OU model jump research paper. Okay, we are getting this, but I'm not sure if this is the correct thing. Okay, pure jump mean reversing a short rate model. So this is basically a market making model. Wait a minute. Market making paper, I believe. Okay, this is the same thing that I opened here, but I'm not sure if this is the thing that I want to do or that I have to do. Like want is not in the question, but what I have to do. Man, I do need to understand a lot of things. Okay, no issues. Actually, the amount of jump that I'm making from this to this is insane, but never mind. I I have to do it. I want to be best. So yeah, let's quickly do this. So in a session we will do this, and in okay, I'm kind of slow in this part, but I believe I can pull this off. Okay, let's just quickly go through this. Where were we? I got stuck, or I do want to learn a concept from here. So let me just see it once. So the property was a plus 0 equal to a, and the a plus minus of a equals to 0, which makes sense algebraically, but yeah. Okay, so yeah, it actually makes sense. I don't think I have to watch it. And 0 matrix is of course 0 in all the columns and rows. All right, and then we have, I will just quickly go through this. uh, okay, can I just zoom it? Okay, then we have matrix multiplication, which is uh, so here I believe mn is rows and columns. I got the PDF link of the paper. I'll just see what it is actually. So I think I got every resource that I should have. Okay, in a session we will just do that. Okay, I'll just continue this. So let's just see the examples. What is happening here? So here mn. So if we have to do um, a cross b, then mn and k. What is this mn and k? I think I have to see from matrix multiplication. Transpose is actually converting the rows into columns, columns into rows. That is it. Yeah, I believe so. We do have a good amount of good chunk of things to study. Okay, also in determinants we haven't learned minus and cofactors. Okay, we didn't learn the term, but we learned how we can just go through this. Okay, so it will be a quick ride. Just have to finish this matrix multiplication transpose. Yeah, and these things make sense. So we have 3-4 topics to study. That's it. There are so many properties, like really so many properties. Okay, I will just put it there. And in case of this, can we just go ahead with matrix multiplication? Yes.
matrix, you can't add any two matrices, right? So if matrix A can be multiplied with matrix B only when the number of columns in matrix A is equal to the number of rows in matrix B. Okay, please understand, it's very important. So if you want to multiply matrix A by matrix B, it can only be done when the number of rows in matrix, sorry, the number of columns in matrix A is equal to the.
Okay, so basically we can only multiply this if the columns and rows of two matrices are equal, like not the columns and rows, but number of columns will be equal to number of rows of that. Okay, makes sense. Let's see how he explains other stuff here.
To
Okay.
the number of rows in matrix B. Okay, and the resulting matrix C, if these two matrices can be multiplied, the resulting matrix C will have the order m into k. Okay. Any doubt over? I think before we discuss whether we have any doubt, let us give an example on how do we multiply two matrices, right? That's important. So let us take one example. So we have a 3, just a minute. We have a 3 into 3 matrix, and then we have a 3 into 4 matrices. Okay, yeah. So first of all, can we multiply these two matrices? For example, let this matrix be A and B. Right? Can we multiply these two matrices? So if you see, A is 3 into 3, and B is 3 into 4. Right? The number of rows are 3, and the number of columns in B is 4. So can we multiply these two matrices? Yes, right? Because if you see, the number of columns in matrix A is equal to the number of rows in matrix B, right? And so we can multiply these two matrices comfortably. And the resulting matrix will have the order 3 into 4, right? So without wasting much time, let us see how do we multiply these two matrices, right? So as you already know that the resulting matrix will have a size of 3 into 4. So let us first create a matrix. So basically 3 rows and 4 columns, right? So 1, 2, 3, and 4. 1, 2, 3, 4, 1, 2, 3. So this is the resulting matrix that I'm proposing, right? So now let us see how we multiply it. So which element is it? Is it C11, right? This one is C12, right? So
Yes.
to get C11, we multiply first row of this matrix and first column of this matrix, okay? So what we do, we add it correspondingly. So 3 will be multiplied with 2, so 3 into 2, plus 5 will be multiplied with 5, plus minus 1 will be multiplied with 9. And that value will be here. So 3, 2 is 6, 5, 5 is 25, minus 9. So it will be 22, right? So that's value will be 22. Now, let's talk about this particular element, okay? I will be repeating this exercise, so please see how we are doing, okay? So this element is nothing but A12, C12, right? So how do we get C12? By multiplying first row of this matrix, right? With second column of second matrix. So this is the second column, right? So it will be 3 into minus 2. If you see, 5 into 0 plus minus 1 into minus 4. So it will be minus 6 plus 0 plus 4. So it will be minus 2. Right? Now let's talk about this particular element. What is the name of this particular element? C of 1, 3, right? So I will not do it consecutively because otherwise it will lead to some pattern, another pattern. So let us do for this particular one. What is its order? It is C. What is the position of this element? C of.
Okay, so it is very, I mean, understandable what and how we are doing this. So if you are doing, like, let me just do it by myself. I'm okay. Should I just switch the screens or what? I think I will just, okay, I can keep the screens too, it doesn't matter. I will just keep my OneNote here. Okay, I have PDF in the second screen, so I can like view, yeah, and also verify the answer if I'm wrong or not. So Oh, let me just start it. Okay, so um so we have this matrix and we have to find its multiplication. So let's write the original values here. Let's say, okay, my bad. Okay, these things are pretty uncomfortable. Like, not matrix, I'm not talking about matrices, but I'm talking about my pen tab. So I will just write the major values here. So we have 3 cross 4 matrix, 3 3 cross 4 matrix. So what we can do is, um, if we have 3 cross 4 matrix, then matrix will also be 3 cross 4. uh, so our first matrix is 3 cross 3, and the matrix is 3 cross 4. So uh, if this is same, we can multiply, and this will be the value of the, not value, but this will be the orientation of the answer of matrices. So 3 cross 4, 4. Now let's just find the matrices to see 1 1 1 1. Yeah, see 1 1 equals to 3 into, so 1 1 basically means uh, rows of this and column of this, correct? So we can figure out rows of this to 3 into 6. I will try to do it verbally. So 3 into 6 plus 25 minus 6 plus 25 minus 9. So 6 plus 25, 31 minus 9 equals to 22. 22. Then we have C12. C12 means 12 means this thing of this matrix and column of this. So C12 would be equal to minus 10, no, minus 6 0 4, minus 604, so it would be minus 2. And next is, so for the third column it would be 9 35 plus minus 1, 35 plus 9, 35 plus 9, 44 minus 1, 43, 43. And then next one is 3 3 plus 40 minus 1, 40, 3 plus 40, 43 minus 1, 42. Again, for next row we have 8, 0, 8 and 18. 8 plus 18, so 26. All right, next one. um, minus 8, 0 and minus 4, minus 8, minus 4, minus 12. No, it's coming out to minus 16. How? Let me just cross verify. So minus 8, 0 and okay, minus 4 into 2, so it will be minus 8, so it would be minus 16. My bad. So next one is 12, 0 and 2. 12, 0, 2, 14. And next one 4, 0 and 2, 6. Now next is minus 12, minus 12, 6. No, sorry. Next one of here is, yeah, minus 12, minus 15 and 18, minus 27, minus 18, so it would be around 9. Let me just recalculate it. um, minus 12, minus 12, minus 15, so minus 27, minus 8, so it would be, we just have to do this, 9. Yeah, comes out to be 9. Okay, why I was just confused in this. There's just difference of 9 even if I read the table of 9, so I fumbled this question. Yeah, so it would be minus of 9 because this is minus and this was in positive. So next one, uh, it's 12, 0 and 8. 12, 0, 8, 20. 12, 0 minus 8. Wait. Uh, so second row. This is for second row, right? Second column. So yeah, 12, 0 and minus 8. It comes out to 4. And next one, it's minus 18, minus 27 and 2. Minus 18, minus 27, so we just have to plus it. 30, 38, 45 and 45 plus, so it is minus 45 minus 2, I believe, minus 2, 43 minus 43. This is nothing, can just erase. Okay, fine. Okay, did I made some calculative mistake? I don't know, I have to check because here answer is 37. So minus 6 into 3, so oh, it would be minus of 18. Okay, and minus of 21. So what I actually placed here, I don't know what I placed here, what I added here, I don't know what I did. So this and then then positive 2, so 30, 39, 39 minus 2, so it would be 37 minus 37. That this would be minus 37. minus 37. Okay, last one. So 2 into 2, 16, and then 2. So 2, 16, 2. So 4, 20. Right? Oh, my bad. What I did, bro. Come on. Uh, minus 6, minus 6, and minus 24, and positive of 2. So 28 minus of 28. It was fun, but I think I really think I need to study this a bit more. Okay. Um I think I should just take the screenshot of matrix multiplication. Matrices, can I just take the screenshot? Screen clipping. Okay. Okay, it was a fun ride. Then their properties in general. A into B is not equals to B into A. Yeah, it totally makes sense, because if we are doing uh, multiplication like this, then if we just switch the terms, then it will produce us a different answer. Okay, let's just read from the PDF only. Properties. All right. So I think only matrix multiplication is important here. Properties can be used to make shortcut of a lot of things. So A into BC is this. Okay, we can club and declub the things. Yeah, makes sense. Make total sense. And what is transpose? Transpose just means to convert the columns into rows into columns. Okay, what is this example? What is this example? I don't know. I have to understand that. And let's just go through what we can understand from this. So if suppose this is transpose of this, yeah, can we transpose it? 15 and 20, 15, 15. Okay. Okay, it will be symmetric when uh, transpose and the original value of the matrix will be same. And what is this skew symmetric? Then when it will be negative of transpose. Okay. Okay, let's see how it went. Fine. And it would be oh yeah, makes sense. So let's talk about diagonal matrix. uh, yeah, so find out how do we create a diagonal matrices in Python. Okay, Only square matrices can be diagonal matrices. Square matrices having non-zero elements only on the main diagonal. Okay. Identity matrices are diagonal matrices having all main diagonals elements is equal to 1. Okay. So this is sample for the identity matrices. Upper upper triangle matrix, lower triangular matrices. All right. So yeah, it's all elements are in the upper terms, and all of these elements are in the lower terms. So basically, what is minor and cofactors here mean? Let's see. So so yeah, let's say um minor of element this would be the multiplication of this. Okay, cross multiplication of this. Okay, I got the minus. What are cofactors? Find the matrix of cofactors. Okay, let me just ask. Minus are pretty clear. What are cofactors? Okay, I think I understood this, but for better clarity, I think I should just watch it. Um, okay, where's the thing? So it was after identity matrices, right? Yeah, it was after all the matrices. So okay, so here we can find minor, but how do we find cofactors? Okay, let me just go back a few seconds. No. Okay.
What you want to say? find out. So what we do is we just multiply with their signs, right? So I told about sign plus, minus, plus, minus, minus, plus, minus, plus, and again plus, minus, plus, minus. So it continues like this. Okay. So to find out the cofactor of this particular element, we multiply its minor with the appropriate sign. So what is the minor of 1, right? So the minor of that particular element is minus 3. We multiply with its proper sign, which is plus, so it will be minus 3 itself. So the cofactor.
That only. So we have to remember the sign convention. Starts with plus, then it just goes on. I will just write it. Can I just take screenshot too? I took wrong screenshot. Okay, let's go. I think we are done with this lecture. I don't think there's more to just think and uh, jump around. So what is inverse of a matrix? So A cross B equals to B equal to inverse of matrix A. Yeah, this is a sample for inverse matrix of cofactors of A. So A equals to this, we can find the determinant of this, alright. And for minus, for inverse of this is just, if this is 10, then it will be 1 by 10. Okay, so if we just into the value of 1 by 10 into all, so it will become this, and then we can find A cross A. Probably I have to see the lecture for inverse too.
Element this one, so you can tell it by multiplying it with. So what we
Okay.
Please.
I got this. Can we just move ahead? Come on.
Yes, it's 2.
Minus
Minus 2.
minus 2 and 2, yeah. I like to calculate cofactor, so it's big. I like to calculate cofactor, so it's easy. Okay, let us just do minor one again. So basically, we need to find the minus of this particular one. So we'll just keeping this particular column and this particular row. So what we will be having is 1, 2, 3, and 4, right? So we'll be having 4 into 1, 1 into 4 minus 3 into 2, right? So it will be minus 2, minus 2. Yeah. B. That 2 itself. Let us one A, so that we get an identity. Doesn't matter, right? So let us say we have one matrix A and then there's matrix I, okay? And I want to say with what matrix, so what matrix should be multiplied with A so that we get an identity matrix, okay? So what matrix should be multiplied with A so that we get an identity matrix, okay? So that's the question. Let us say there is a matrix B which when multiplied with matrix A we get an identity matrix, okay? So this particular matrix B is called inverse of A, inverse of matrix A, okay? Any doubt? So basically the thing is A into its inverse is just an identity matrix. I repeat, an identity matrix is a matrix having non-zero element only on the main diagonal, and all other elements are zero, and the non-zero elements are one itself, okay? So for example, I2 was 1 0 0 1, I3 was 1 0 0 0 1 0 0 0 1, right? So identity matrix will be having 1 on the main diagonal and all other elements will be 0, okay? Any questions so far? And to find out the inverse of a matrix A, what you need to do is that you need to take the transpose of the matrix of cofactors of A, that transpose, okay, divided by its determinant, okay? So that will be the inverse of matrix A, okay? Any doubt? So can anyone quickly find out the determinants of matrix A? So let us take one example. What I'm saying, the matrix A that we have taken is taken was minus 1 1 2 3 minus 1 1 minus 1 3 4. Can anyone quickly find out determinant of this particular matrix? So how to find determinant? Minus 1 into so 3. How much are we getting? 4. 4. Everyone is getting 4?
There was a condition for the existence of inverse as well, right? What was
Yeah,
that?
I will be telling you, right? I will be telling it. I will be telling you.
Okay, okay.
I'm just giving a practice class. Guys, what will be the determinant of this particular matrix? Everyone forgot or what?
I think I'm getting 10. Yeah, when I'm getting.
Okay, so minus 7 minus 13 plus 16. Yeah, so it will be 10. Okay, so please cross check it out. Right now, we have already calculated the matrix of cofactor of A, right? So we just need to take its transpose, right? So matrix of cofactor of A was this one, right? So if you take its transpose, so it will be, let me write it down. So transpose will be, so on the numerator, we have transpose of the matrix of cofactor, right? So let me write it down. So this will be minus 7 minus 13 8, 2 minus 2 2, and then 3 7 minus 2. So this is the matrix of transpose of A. Sorry, transpose of matrix of cofactors of A, right? As per the formula, and this will be divided with the determinant, right? And then you will be getting the inverse of A, right? What is the determinant? Determinant is 10. So this has to be divided by 10, or it means we have to multiply this particular matrix by 1 by 10, right? So by 10, right? You will be getting the transpose of minus 7 minus 13 8, 2 minus 2 2. Will be, so on the numerator, we have transpose of the matrix of cofactor, right? So matrix of cofactor of A was this one, right? So if you take its transpose, so it will be, let me write it down. So transpose will be, so on the numerator, we have transpose of the matrix of cofactor, right? So let me write it down. So this will be minus 7 minus 13 8, 2 minus 2 2, and then 3 7 minus 2. So this is the matrix of transpose of A. Sorry, transpose of matrix of cofactors of A, right? As per the formula, and this will be divided with the determinant, right? And then you will be getting the inverse of A, right? What is the determinant? Determinant is 10. So this has to be divided by 10, or it means we have to multiply this particular matrix by 1 by 10, right? Divided. So this is the matrix of transpose of A. Sorry, transpose of matrix of cofactors of A, right? As per the formula, and this will be divided with the determinant, right? And then you will be getting the inverse of A, right? What is the determinant? Determinant is 10. So this has to be divided by 10, or it means we have to multiply this particular matrix by 1 by 10, right? 0.7. So A inverse will be minus 0.7, 0.2, 0.3, minus 1.3, minus 0.2, 0.7, 0.8, 0.2, minus 0.2. So now this is your inverse of A. So how do you find inverse of A? First of all, you need to find out minus of matrix A, then matrix of cofactors of A, then you take its transpose, put it in the numerator, find the determinant of the matrix. Sorry, the first class, okay, I will be telling the first class after this. You find out the determinant of the matrix A and then divide the numerator by the numerator, you get the inverse of matrix A. So this is the inverse of matrix A. Matrix A, what was matrix A? This was matrix A, right? Now multiply matrix A with A inverse and tell me what are you getting. You already have matrix A and you now have got matrix A inverse as well. Now multiply these two matrices. So basically you need to multiply A with A inverse and tell me what you are getting.
So
Okay,
just we'll take the transpose of the matrix of
I believe this is kind of complicated, but yeah, works.
cofactors of A, right?
Right, yeah, right. So
Okay.
transpose. So in the numerator we have transpose of the matrix of cofactor. So for once we have found out the cofactor of matrix A, we need to take the transpose and put it in the numerator. Then we need to divide it by the determinant, and then just do the scalar multiplication. You get the inverse of A. So the current task that I have activity that I have said is find out what is A into A inverse. So multiply A with A inverse and tell me what you are getting.
Identity.
Yes. So I think, and not I think, you must get 1 0 0 0 1 0 and 0 0. So obviously this is what you have to get because that's the concept of inverse, right? So when you multiply a matrix with its inverse, you get uh, an identity matrix. Now tell me one thing: if you look at this formula, right, and in the denominator you have something like determinant of A. So this should give you a hint of what should not happen, right? This should give you a constant, right?
It should not be 0.
Yeah, so determinant of A should not be 0. So this is the first step that I was referring to. So to inverse to exist, the determinant of the particular matrix should not be 0. So this is the first step that you need to take. For example, the matrix that I was discussing, 1, 2, 3, 4, 5, 6, 7, 8, 9, the determinant of the particular matrix was 0. So don't start with minus and cofactors first, okay? First start with the determinant and check whether the determinant is 0. If the determinant is 0, then inverse does not exist. So no need to find out the minus and cofactors, right? So first of all, you need to find out the determinant and then continue with the matrix of cofactors, okay? Got it, everyone? And so first of all, you need to find out the determinant and then continue with the matrix of cofactors, okay?
Yeah, so in this we first of all we have to calculate the determinant, then we have to find the matrix of cofact. No, first wait, what he actually said at the end.
Minus and cofactors, right? Determinant is 0. If the determinant is 0, then inverse does not exist. So no need to find out the minus and
Yeah, okay, so first we have to find determinant, and if determinant is non-zero, then we can find uh, a matrix of cofactors, and if it's zero, then inverse doesn't exist. So it's like that. Okay, I think that was it.
cofactors, right? So first of all, you need to find out the determinant, and then if you take the inverse of inverse, you get the matrix A itself, okay? So now if you go and find out the inverse of this matrix, you will get the inverse. If you have any doubt, feel free to ask.
Shit.
Okay, then I think we finished this thing. There are more. Let me just check what is it. So it's basically a system of linear equations, how to find eigenvalues, how to rank, how to find rank of a matrix. Okay, so this is the next thing that I want to do. Okay, I should close this. I do have to attend a session of Black-Scholes model right now. uh, we need to catch up to this by finishing the primers. After primers, probability and stats. I will go slow here. I want to build a good foundation of probability and stats, because we'll be solving green book after this, I believe, and I would refer to MIT's course of probability and stats for problem solving. So this would be our main core thing that I really want to do. Okay, and this is the mainly the um, this is mainly the ML for quant. Yeah, fine. Okay, I do want to read um this thing. And I believe, oh, there was somewhere normal distribution. I don't know where, but I saw somewhere about normal distribution. Yeah, probably here only.
So hi everyone, welcome to this particular lecture wherein we will be discussing normal distribution. So the basic theoretical concept have already been covered in module 2C.
Okay, so let me just see what is it. Normal distribution is in 2C. Okay, so 2C. Bro, can't I just download it? Okay, okay. It got opened at the end. So continue. Normal variations, variables. I just want a basic definition of normal distribution so that I can just get the idea of it. Can I just ask this guy what is normal distribution? Okay, got it. So normal distribution is a bell shaped, like here only na we had normal distribution. This is so these are the most likely values and these are the like less likely values. Okay, okay, actually we not we but I need to study a lot. There are a lot of things to learn. And also I have to prepare some competitive programming skills too because I do want to um, the competition in which I will be participating for recruiting, it do require a good competitive programming skills, so I need to learn some C++ too. I will skip this thing for a while. I will learn basic mathematics behind everything first, and after that I can go into more wider scale. Okay, can I see the collab file? Like what actually is it? If it's from basic to intermediate, so it should have included a lot of things. Okay, so we read till operators. Um, there are a lot of operators. I have to revise some of the functions. Okay, fine. Alright, I should just end the stream here because I don't need to uh, jumble a lot of things. I just need to do things sequentially. So I will just finish these primers as quickly as possible within this week, and I need to study this properly. Okay. Okay. All right.